Our today's talk is about the matrices for J plus operator. We know that when J plus operator acts on Jm, we get the value h bar under root j minus m into j plus 1 plus m, and the matrix element is given by this into delta j dash j delta m dash m plus 1. Now let's see what will be the matrix for J plus when j is equal to 0. When value of j is 0, m will be 0 and we will get rank of the matrix as 1 and it will be a null matrix. Next is when j is equal to 1 by 2, m can have value minus 1 by 2 and 1 by 2. Dimensionality of the matrix will be given by 2j plus 1, that is it will be now 2 by 2 matrix. The matrix will be written as the different states will be 1 by 2, minus 1 by 2 and 1 by 2, 1 by 2. Matrix will be written as Jm along y-axis, j dash m dash along x-axis. It will be 1 by 2, minus 1 by 2, 1 by 2 and 1 by 2. 1 by 2, minus 1 by 2, 1 by 2, 1 by 2. Let's see which element will exist. For this element, value of m is minus 1 by 2. That of m dash is minus 1 by 2. So this element will not exist. For this element, m is minus 1 by 2 and m dash is 1 by 2. In this case, as m is minus 1 by 2 and m dash is 1 by 2, the value of m plus 1 will be equal to minus 1 by 2 plus 1, that is 1 by 2, which is equal to m dash. So this element will exist. Here, value of m is 1 by 2, that of m dash is minus 1 by 2. That means m plus 1 will be equal to 3 by 2. So even this element will not exist. For this element, m is 1 by 2 and m dash is 1 by 2. So m dash plus 1 will be equal to 3 by 2. Even this element will not exist. For this element to exist, the value of element will be given by under root j minus m into j plus m plus 1. So that means it will be 1 by 2 for this 1 by 2 and value of m is minus 1 by 2. So it will be 1 by 2 plus 1 by 2 into 1 by 2 minus 1 by 2 plus 1 under root. That means it will be under root 1, that is 1 into h bar. So the matrix will be matrix will be 0, h bar, 0 and 0. This is the matrix for J plus when J is equal to 1 by 2. Let's see what will be the matrix for J plus. Matrix for J plus when J is equal to 3 by 2. Yeah, first of all, let's do that for 1. Matrix for J plus when J is equal to 1. M can have value minus 1, 0 and 1. The three states will be 1, minus 1, 1, 0 and 1, 1. Dimensionality is given by 2j plus 1, that means 2 plus 1, that is 3. So it will be a 3 by 3 matrix. The matrix can be written as 1 minus 1, 1 0, 1 1, 1 minus 1, 1 0 and 1 1. Jm along x-axis and j dash m dash along y-axis. J dash m dash along x-axis and jm along y-axis. Let's see which elements will exist. In this, the delta factor is given by delta j dash j and delta m dash m plus 1. That is, only that element will exist where m dash is equal to m plus 1. In this state, m dash is minus 1 and m is also minus 1. So this element will not exist. In this case, m dash is equal to 0 and m is equal to minus 1. So minus 1 plus 0 is equal to minus 1 plus 1. This will be 0. So that means this element will exist. In this case, m dash is 1 and m is minus 1. So m plus 1 is equal to 0. So even this element will not exist. For this line, m is equal to 0. So m plus 1 will be equal to 1. Only that state will exist where m dash is equal to 1. Let's see. Here m dash is minus 1, so this state will not exist. This state will not exist, but this will exist. In the third line, in the third row, m is equal to 1. So m plus 1 will be equal to 2. That means only that state will exist where m dash is equal to 2. We do not have any state with m dash is equal to 2, so no element will be there. We will have only two elements. Let's get the value of these two elements. The value of the element is given by, in units of h bar, it is j minus m into j plus m plus 1. For this element, m is minus 1. For m is equal to minus 1, value will be 1 plus 1 into 1 minus 1 plus 1 under root. That is 2 into 1 under root, that is under root 2 in units of h bar, otherwise under root 2 h bar. For this element, m is equal to 0. So the value will be 1 minus 0 into 1 plus 0 plus 1. So it will be equal to, once again, it will be equal to under root 2 h bar. The matrix for j plus, when j is equal to 1, is given by 0 under root 2 h bar, 0, 0, 0 under root 2 h bar, 0, 0, 0. Now let's move to the matrix for j minus. Matrix for j minus. The matrix element is given by j dash m dash, j minus, jm, and this is equal to h bar under root j plus m into j minus m plus 1 delta j dash j delta m dash m minus 1. For j to be equal to 0, it will be a null matrix. Let's move ahead and get the value of this matrix when j is equal to minus 1 by 2. When j is equal to 1 by 2, m can have value 1 by 2 minus 1 by 2. Dimensionality will be given by 2j plus 1, that is 2 into 1 by 2 plus 1, that is, it will be 2 by 2 matrix. The elements will be Jm and J dash M dash. 1 by 2 minus 1 by 2, 1 by 2 and 1 by 2. Similarly, 1 by 2 minus 1 by 2, 1 by 2, 1 by 2. Let's see which element will exist. In this, only that element will exist where m dash is equal to m minus 1. For the first row, m is equal to minus 1 by 2. For this element, value of m dash will be equal, m dash is equal to minus 1 by 2, but for this value of m dash should be equal to minus 1 by 2 minus 1, that is minus 3 by 2. So no element will exist here. For the second row, m is given by 1 by 2. It is given to us that m is 1 by 2. M dash will be equal to 1 by 2 minus 1, that is minus 1 by 2. Only that element will exist where m dash is equal to minus 1 by 2. So at this place, m is 1 by 2 and m dash is minus 1 by 2. So this element will exist. Here m is 1 by 2 and m dash is 1 by 2. So this element will not exist. Let's get the value of this element. For this element, m is 1 by 2, m dash is minus 1 by 2 and j is 1 by 2. Element will be under root j plus m, that is 1 by 2 plus 1 by 2 into j minus m plus 1 under root in units of h bar. So 1 by 2 plus 1 by 2, 1 by 2 minus 1 by 2 into 1. The element will be, here the element will be, it is j plus m. So j is 1 by 2. It will be h bar under root 1, that is, it will be h bar. So matrix will be 0, 0, h bar 0. Let's write down matrix of j minus with j is equal to 1. M can have 3 values. Those 3 values will be minus 1, those 3 values will be minus 1, 0 and 1. Dimensionality is given by 2j plus 1. So dimensionality will be 3. It will be a matrix of 3 by 3. Let's write down the matrix. The elements will be 1, minus 1, 1, 0 and 1, 1. Similarly, 1, minus 1, 1, 0 and 1, 1. It is Jm on this side and J dash M dash on this side. Let's see which element will exist. Only those elements will exist where M dash is equal to M minus 1. For this row, M is equal to minus 1. So M dash will be equal to minus 1, minus 1. That is minus 2. Here we do not have value of minus 2 for M dash. So no element will exist in this row. For the second row, value of m is 0. So m dash which should exist should have value 0 minus 1, that is minus 1. First element of this row has got value of m dash as minus 1. So this element will exist here. M dash is 0. Here m dash is 1. For the third row, m is 1. So m dash to exist, m dash should have value 1 minus 1, that is 0. This element will not exist, but this will exist. This element will not exist. The value of element is given by under root j plus m into j minus m plus 1. For this element, value of m is 0 and value of j is 1. So the value comes out to be under root 2h bar. This comes out to be under root 2h bar. Similarly, this element comes out to be under root 2 into h bar. It will be 1 plus 0 into 1 minus 0 plus 1 under the root. So it is under root 2. Here it will be 1 plus 1 into 1 minus, here m is 1. So value will be under root 1 plus 1 into 1 minus 1 plus 1. Once again under root 2h bar. So the matrix comes out to be, matrix will be 0, 0, 0, under root 2 h bar, 0, 0, 0, under root 2 h bar and 0. Let's do one more example for J minus matrix with J value equal to 3 by 2. J minus matrix with J value to be equal to 3 by 2. If J is 3 by 2, M can have value 3 by 2, 1 by 2, minus 1 by 2 and minus 3 by 2. Rank will be 2J plus 1, that is 2 into 3 by 2 plus 1. So it will be 4 by 4 matrix. Dimensionality will be 4. Let's write down matrix and the different states. Different states will be 3 by 2 minus 3 by 2, 3 by 2 minus 1 by 2, 3 by 2, 1 by 2 and 3 by 2, 3 by 2. Here it will be 3 by 2 minus 3 by 2, 3 by 2 minus 1 by 2, 3 by 2, 1 by 2, 3 by 2 and 3 by 2. It is Jm and J dash M dash. Only those elements exist for which value of M dash is equal to M minus 1. For first row, M is minus 3 by 2. M dash to exist, it should have value minus 3 by 2 minus 1. That is minus 5 by 2. We do not have any value of M dash as minus 5 by 2. So this element will not exist. For second row, M is minus 1 by 2. For element to exist, M dash should be equal to minus 1 by 2 minus 1. That is minus 3 by 2. So minus 3 by 2 is this state. M dash minus 3 by 2 is this state. These elements will not exist. For third row, M is 1 by 2. For state to exist, M dash should be equal to 1 by 2 minus 1, that is minus 1 by 2. This is the only state where we have got M dash as 1 minus 1 by 2. For the fourth row, M is 3 by 2. For the element to exist, M dash should be equal to 3 by 2 minus 1 by 2. So that means we should have this value as 3 by 2 minus 1, that is 1 by 2. So this state will not exist, this will not exist. Here we have got value of m dash as 1 by 2. So this element will exist, this element will not exist. Let's calculate the values. The element has value as under root j plus m, j minus m plus 1. J for all these values is equal to 3 by 2. First row has got no element. Second row has got one element. For second row, m is minus 1 by 2. If we calculate the value with j is equal to 3 by 2 and m is equal to minus 1 by 2, the element comes out to be under root 3. It will be 3 by 2 plus 1 by 2 into 3 by 2 minus 1 by 2 plus 1 under root. So this is equal to under root 3. For third row, m is 1 by 2. J is of course under root 3. J is 3 by 2. M is 1 by 2. The value comes out to be 2. So this element will have value 2. For the last row, m is equal to 3 by 2. J is equal to 3 by 2. The value comes out to be under root 3. Let's write down the value matrix with these values. These are the three values, and matrix is a 4 by 4 matrix. First row had no element, second row had first element. So second row has first element. We will have that first element came out to be under root 3 h bar 0 0 0. Second row, this element was existing with the value 2. In the third, we had under root 3 h bar 0. This is the matrix element of J minus, matrix representation of J minus with J is equal to 3 by 2. Using the same technique, we can write down the matrices for ladder operators for orbital angular momentum as well as spin angular momentum. If somebody asks us to write down the matrix for L square or S square or LZ or SZ or L plus, L minus, S plus or S minus, using the same technique we can write down those matrices.